start a new chapter, that is chapter number 10 on circles. It's a very short chapter, and it's very scoring also, because the problems which are given on this chapter are not of many different types. So what is a circle? Circle, as we studied in the previous classes, it is a collection of points on a plane which are equidistant from a center. So if we have a collection of points and there is a point which is from which they are equal in distance, then the arc that we will draw through these points will be a circle. So I connected all the dots by this arc, and we get a circle. The line drawn from the center to the circumference is what? It's a radius. Sorry. So this line is the radius, and suppose I take some points. This point, this point, this point, this point, this point. These are inside the circle, and this point, this point, this point, these are outside the circle, and the point is this point is on the circle. So a straight line drawn which passes through the center. Okay, so this is a diameter, dia. This is your radius. So this is the radius and this is the diameter. Diameter is twice this the length of radius. And we now go through the concept of chord and secant and tangents. So if I take 2 points on the circle, let us suppose point A and this be point B, and if I join these 2 points, then I get chord. And so a chord which passes through the center of the circle will be what? It will be the largest chord, and it will be your diameter. Now if a line is drawn now from a point outside the circle, okay, and if it touches the circle in only one point only, then that line is known as tangent. On the other hand, if a line touches a circle in 2 points, suppose I draw a line and this is it touches the circle in point P and Q, not in one point as it was here. So this line will be known as secant. So secant intersect because it is cutting the circle. So it intersect the circle at 2 points. and tangent touches the circle at one point. Second, intersect. It cuts at 2 points. Tangent doesn't cut, it touches the point. So, how many seconds can we draw from a point outside the circle to on a circle? It is infinite. But what about the tangents? How many tangents can we draw from one point? We can draw only two tangents. This is the one is shown in the figure, and other one will touch the circle on the other side. So it is touching at point this. So we can draw at most only two tangents from a point outside the circle. But the number of tangents which can be drawn from are infinite, not from a point, from anywhere, from any point outside the circle. From here we can draw two lines. From here I can draw two, sorry, two tangents here. From here, two tangents. From here, two tangents. So we can draw infinite tangents from different points. Now, what are the properties of this tangent? That we will study, and that is the focus of this chapter. So, we go to the first theorem. It states that the tangent drawn to a circle from a point outside the is so what it says that if we draw a tangent to circle, then the radius drawn from the center to the point of contact will be perpendicular to the tangent. So now we have to prove that this angle is 90 degree. Which angle? The point of contact. The angle drawn by radius at the point of contact with the tangent. This angle is 90 degree. That means that a radius is perpendicular to the tangent. So let us assume that this is not a 90 degree, and we have another point R dash such that it makes an angle of 90 degree. But if it makes an angle of 90 degree, then so OR dash, if I draw a line parallel to PR, let it be OP dash, then what we assume by construction that OR dash is perpendicular to PR. So this must be the shortest distance, because from a point outside a line to the line, the shortest distance is the line perpendicular to it. So the R dash, if R dash is the shortest distance between O and this line PQ, then it must be R dash must fall on the circumference of the circle. So if r dash falls on the circumference of the circle, then what will happen? We have 2 points r and r dash. So this line must cut the circle at 2 points. So it cannot be a tangent, it should be a secant. So that means that there is no any other point on this line which is perpendicular to this line drawn from center O. So it must be only the point R where the tangent touches the circle. That is the point of contact. So we have proved that the line drawn from the center of circle to the tangent through the point of contact is perpendicular to it. Now we have one more theorem. So the theorem states that the two tangents, because we know that we studied here that we can at most draw two tangents from a point outside the circle. So what this theorem says that these two tangents drawn from the point outside the circle are equal. That means A from A point to this point of contact, from A point to this point of contact. This distance should be equal. So let us prove this. So we have drawn from point P two tangents to the circle, PQ and PR. Now we have to prove that PQ and PR are equal in length. So what do? We do some construction to prove this. So one thing that I do is I join the point P to the center of the circle, and from the center of the circle I draw a radius which touches the point of contact of the tangent. So I drawn two radii, and this radii touches at the point of contact of the tangent. So we know that radius the line drawn from the center to the point of contact of the tangent is perpendicular. So this angle is 90 degree. Similarly, OR is the radius and it touches the point of contact of the tangent, so it is perpendicular. So this angle is also 90 degree. This side and this side are equal. Why? It is because both are radius and this side is common. So these two angles are equal, hypotenuse is the same, and the side is equal. So by RHS, write hypotenuse and side. These two triangles are congruent. So in triangle POQ and triangle POR, PO is common. Angle Q and angle R are both of 90 degree. And angle Q is equal to angle R is equal to 90 degree. Why? From theorem 1, and OQ is equal to OR. Why? Because both are radius. So these two triangles become congruent. So triangle POQ is congruent to triangle POR by R. So these two triangles are congruent. That means PQ is equal to PR, and they are congruent by the rule RHS. Right hypotenuse and side. Right angle, this is the common hypotenuse, and these two sides are equal. So we get finally PR is equal to PQ. So we get PR is equal to, so we go to the exercise 10.1. The question is how many tangents can a circle have? So what do you think the answer could be? It is infinite, of course. So the answer is infinite. Why? Because any circle has infinite points on the circumference. You cannot count the number of points on a circle. Can we count how many points are there? Infinite. So from at each point we can draw a tangent. So this is the answer. A tangent to circle intersects it in, of course, it is one point, because if it intersects at more than one point, then it is a secant. A line intersecting a circle in 2 points is called a secant, because if it intersects at one point, then it is called tangent. And if a line intersects at 2 points on a circle, then it is called secant. A circle can have parallel tangents at most. So how many parallel tangents can a circle have? So there can only be two parallel tangents. You see. So let this be a circle. So we can draw a line is drawn which is a tangent to the circle. So all other lines drawn will be secant. And we will get only another one more line which will be tangent to this circle, because if we draw other parallel lines and all these parallel lines intersect the circle at more than one point, so we can have at most only two parallel tangents. The common point of a tangent to a circle and the circle is called point of the contact. In the question number 3, we are given that there is a circle and the radius of circle is 5 centimeter. So this is the center of the circle. The center of the circle is O, and this length is 5 centimeter. So from a point P, and there is a point P on the circle, and a tangent PQ is drawn. So this is point P. This is point Q. And OQ A line which passes through the center of the circle OQ is 12 centimeter. So we are asked to find the length hypotenuse. So hypotenuse, and we need to find out QP. So QP will be by the Pythagoras theorem. So in triangle QOP, angle P is 90 degree, QO is hypotenuse. So QO square is equal to QP square plus OP square. We are given QO, we are given PO. Sorry, this is OP square. So we can easily find out QP square. QP square will be QO square minus OP square. So it will be 144 square minus 25, that is 119. So it is root of 119. So D is the answer here. So by inputting the values, we get QP square is equal to 144 minus 25, or QP is equal to root of 119. So the answer is here D. Now we go to the question number 4. Draw a circle, two lines parallel to a given line such that one is tangent and the other one is secant to the circle. So we have a circle and we need to draw two lines parallel to a given line. Let the given line be this line. So one line is tangent to the circle. So this line we have drawn tangent to the circle, and the other line should be secant to the circle. So you can draw anywhere such that it intersects the circle at 2 points. So we have drawn two lines, one is tangent and another one is secant to the circle. So this completes our exercise 1. So we start the exercise 10.2. So the first question is, from a point Q, the length of the tangent to a circle is 24 centimeter. So the length of tangent is 24 centimeter and the distance of that point from which the tangent is drawn is 25 centimeter. And we are required to find the radius of the circle. So we draw a figure. So this be a circle and this be the point Q. So this is the point Q from which we have drawn the tangent, and the length of the tangent is 24 centimeter, and the distance of the Q from the center is given as 25 centimeter, and we need to find the radius. So I have drawn the figure, and you see the line tangent to a circle subtend an angle of 90 degree with the radius at the point of contact. So this angle is 90 degree. So this triangle, I will name it. QP is the tangent, QO is the distance of the point Q from O, the center of the circle, and QOP is a right angle triangle. So by Pythagoras theorem, this is hypotenuse. Square of hypotenuse is equal to sum of the squares of the side. So we will write it and we will find OP by Pythagoras theorem. So by Pythagoras theorem, QP square plus OP square is equal to QO square. Now we input the values provided in the question. So input 24 in place of QP and 25 in place of QO. So we get OP square is equal to 625 minus 576, and so OP square is equal to 49, so that means OP is equal to 7. So the radius of the circle is 7. So the correct answer is this one. This one is the answer. Now we go to the question number 2. So this is a very simple question. From point T, two tangents are drawn, TP and TQ. Yeah, and at the center, now this arc subtends an angle of 110 degree. So this angle we know that how much it would be. Tangent is perpendicular to the radius at the point of contact. So both these angles are 90 degree. So this is 90 degree and this angle is also 90 degree. And the sum of the four angles of a quadrilateral is 360 degree. So sum of this angle plus this angle plus this angle is 290. So this angle must be 70 degree. We subtract it from 360 because the sum of all four angles should be 360, and we are already given three angles, 90 plus 110 200, 200 plus 90 290. So this angle should be 70 degree to make the sum of all the angles of a quadrilateral equal to 360 degree. So B is the answer. Now we go to the question number 3. Question number 3, we are given that there are two tangents drawn from point P. One is PA, another one is PB. And they are inclined to each other at an angle of 80 degree. So we draw two tangents. Let this be the point P. So, and this is the one tangent PA. And now let us draw another tangent at point B. Now in this figure, we are given that angle APB is equal to 80 degree. So angle APB is 80 degree, and these angles we know that tangents subtend an angle of 90 degree with the radius at the point of contact. So this is 90, and this angle is also 90. Now we can easily find out this angle because this is a quadrilateral. So sum of the angles of a quadrilateral is 360 degree. So this angle should be how much? 90 plus 90, 180, 180 plus 80, 260. So this angle must be 100 degree. To make sum of the angles of a quadrilateral, 360 degree. So, our angle AOB is 100 degree, and we are asked to find angle POA. And if you see the triangle POA and POB, these are congruent. Why? Because this is a right angle, this is a right angle. This side is common, this side is equal, both are radius. So these two triangles are congruent. So angle PO. So in the question number 4th, we are required to prove that the tangents at the end of a diameter of a circle are parallel. We know the properties of parallel lines. So what are the properties of parallel lines? So these two are the parallel lines. We can name them L and M. M are the two parallel lines, and this is a transversal. So if these two lines are parallel, then we have studied in the past that if two lines are parallel and a transversal is known, then the alternate opposite angles are equal. This angle is equal to this angle, and corresponding angles are equal to the same angle, this one. And the sum of interior opposite angles is 180 degree. So sum of this angle and this angle is 180 degree. So if any of these properties are there, then we can show that we can say that the two lines are parallel. So let us see uh, the figure that we have known as per the question number 4. So in the figure you see that tangent is perpendicular to the line drawn from the center of the circle to the point of the contact of the tangent. So this angle is 90 degree. So both these angles are 90 degree. So what we find here? Alternate opposite angles are equal. Sum of the interior opposite angles is 180 degree. So using this property, we can say that these two lines, if I name them not PL but R and S, these are the two tangents which are passing, which touches the circle at point P and Q, and PQ is a diameter of the circle. Then R and S are parallel because alternate opposite angles are equal, and you can also say that sum of interior opposite angles is 180 degree. Easy. So this is how we can prove this. So I am writing what we have discussed so far. That draw two lines R and S, tangents at the diameter of the circle with center O. So line touches the circle at point P and Q respectively. So we need to prove that R is parallel to S. So angle. So I named these angles as 1, 2, 3, 4. So we see that angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Why? Because PQ is a diameter and it subtends an angle of 90 degree at the point of contact with the tangent. But what? But 1 and 3 and 3 and 2 and 4 are interior opposite angles. We can say that line R is parallel to and this is what we were asked to prove. Now let us go to the second question, that is question number 5. The question number 5 is to prove that a line which is perpendicular to a tangent passes through the center of the circle. So in the theorem in the given in the chapter circle, here one of the theorem is that a tangent, that there will be a tangent to a circle, then the line drawn from the center to the point of contact is perpendicular to the tangent. So now we are required to prove the reverse of that theorem, that a line is perpendicular to the tangent and we need to prove that that line passes through the center. So what we will do is we assume that there be a point R such that RQP is perpendicular to the circle and RQ is the diameter. Since RQ is the diameter, so angle Q is 90 degree. Why? Because of the same theorem. So if angle RQP is 90 degree and OQP is also 90 degree, that means that O must fall on the line RQ. Hence, line OQ will pass through the center. So how we proved? We assume that there be a point R and RQ is the diameter of the circle and Q is the point of the contact. Point of the contact, the point at which the tangent meets the circle. and RQP will be perpendicular. Oh, sorry, will be of 90 degree because of the theorem that line drawn from the center of the circle to the point of contact of the tangent is perpendicular. So if RQP is 90 degree, and we are already given that OQP is 90 degree. So that implies that O must fall on the line RQ. So we are given that QO is perpendicular to PQ. It is given in the question that perpendicular at the point of contact to the tangent. So we have assumed that not we take that OQ is perpendicular at the point of contact of the tangent to the circle. And we don't know whether it passes through the center or not. But we take, now this is what we do. We take a point R such that RQ is the diameter of the circle and it touches PQ at the same point. At the same point where the Q is the point of contact. So at the same point, a line drawn from R to the center touches this tangent. But since by the theorem, so this is by the theorem, so RQ will also extend an angle of 90 degree on PQ. So what we get, angle RQP. So angle RQP by theorem is 90 degree. And we are already given angle OQP is also equal to 90 degree. So let this be 1 and this be 2. So from 1 and 2, what do you get? So we get that there cannot be two lines perpendicular to a line and at the same point. We cannot have this line perpendicular, another line also perpendicular at the same point, another line perpendicular at the same point. So that means that O must lie on RQ. If there cannot be two lines perpendicular to a line at the same point, that means that O must lie on the same line. These two lines must be the same. That means that QO line passes through the circle. In the question number 6, it's a very easy question. It's based on the Pythagoras theorem. We are given that the tangent, the length of the tangent is 4 centimeter from the point A. This is our point A. And the distance of point A from the center of the circle O, that the center of the circle be O, is 5 centimeter. And we need to find the radius. So let us draw radius from point O to let this be point B. So I have drawn line OB from the center to the point of contact of the tangent. And we know that this line is perpendicular to the tangent. Line drawn from the center to the point of contact is perpendicular to the tangent. So this line OB is perpendicular to AB by the theorem. So in triangle OAB, angle B is 90 degree, and this is our hypotenuse, and rest are two other sides. So AO square will be equal to AB square plus BO square. AB square is given, we need to find BO square. So we write the Pythagoras theorem for the triangle, right angle triangle ABO. So in triangle ABO, we get AO square of hypotenuse is equal to sum of square of sides. So AO square is equal to AB square plus BO square or OB square. Now we know AO is 5 centimeter, AB is 4 centimeter. So we need to find OB square. So we'll input these values in the equation to find out OB. So by inputting the values of AB and AO, we get 5 square is equal to 4 square plus OB square. That means OB square is equal to 5 square minus 4 square or 25 minus 16. OB square is equal to 9, hence OB must be 3 centimeter. So in the question number 7, it looks tricky, but in fact it is easy. We are given two concentric circles. Concentric means the circle which have the same center. So let the center be O. So these two circles have the same center O. And the radius of one circle means the larger one is 5 centimeter and the smaller one is 3 centimeter. So this radius is 5 centimeter, and so I have drawn as per the question one circle of radius 3 centimeter. So the smaller circle is 3 centimeter, the larger circle is 5 centimeter, and I have drawn a chord and it touches the inner circle, that means the smaller circle at the point, let's say P. So it touches the point P. So what do you see? If this is a point, we say R or Q, then QP is what? It is tangent to this circle. So this angle must be 90 degree. And what about OQ? OQ is the radius of the larger circle, and OP is the radius of the smaller circle. So so we are given OQ and we are given OP, and we need to find QP and the length of the chord. So this length of the chord is Q, and this point be, let's say, R. So we need to find QP. And what do you think? QP will be equal to PR? Yes. Why? Because these two angles are 90 degree. This side is equal to this side, and this side is common. So this triangle OPQ is similar, congruent to triangle OPR. So QP is equal to QR. PR. And if we find QP, then the double of it will be QR, and that will be the length of the chord. So let us see first triangle OPQ, in which angle P is 90 degree. So let us see angle OPQ. Angle OPQ is 90 degree. Sorry, I will make all these name of the vertices in bold. So why OPQ is 90 degree? Because of the theorem that line drawn from the center of the circle to the point of the contact of the tangent is perpendicular. So in a right angle triangle, what we'll do? We'll apply Pythagoras theorem. We'll apply Pythagoras theorem to find out the side. Which side? The side QP. So from the Pythagoras theorem we get QO is 5, OP is 3. We need to find QP. So input the value of QO is equal to 5 and OP is equal to 3. So by inputting this value we get QP square is equal to 16 or QP is equal to 4. And we have previously discussed that these two triangles in the triangle OPQ and OPR are congruent. So QP is equal to PR. So QR is equal to 2 times QP. Hence QR is equal to 2 times QP. That is QR is equal to 8 centimeter. Why we can write a reason here, because QP is equal to QR. So in the question we are to prove that AB plus CD is equal to AD plus BC. So we can see from the figure drawn that a lot of tangents are drawn from various points. So from point A, the tangents are AP and AS. From point B, tangents BP and BQ. From C, CQ and CR. And from D, you see tangent DR and DS. So which property should we use to prove that AB plus CD is equal to AD plus BC? And you see that these are the tangents. So of course, the property is a tangent drawn from a point outside the circle are equal. And so dr is equal to ds, as is equal to ap, pb, bp is equal to bq, cq and is equal to cr. And how will we get cd, ab, da, cd? By adding these values cr and dr, ds and sa. So we'll write all these equations and we'll add them. So that will give us the final answer. So from point D, dr and ds, these are the two tangents. So dr is equal to ds. Similarly, from point C, cr and cq are tangents. So cr equals cq. So I'll write all these. So I have written that the tangents drawn from points respectively A, B, C, D are equal. So dr equals ds, cr equals cq, ap equal as, and bp equal bq. So while writing these equality, we need to take care that what we have to prove. We have to find out proof that a CD plus AB is equal to AD plus CB. So we have to write in the order such that we get by adding these we get these sides. By this is segment, if we add these segments, so we should get this segment. So dr is equal to ds. So I have written cr is equal to cq. I have not written cq is equal to cr. Then I will not be able to get this side cd. So you need to take care what to write first in this equality. So if we add 1, 2, 3, 4, what we get? dr plus cr plus ap plus bp is equal to ds plus cq plus as plus bq. And dr plus cr is drcr is dc or cd. ap plus bp is ab. Similarly, ds plus as, ds as is ad. And cq plus bq is bc. So, as we have proved. In question number 9, we are given that there are two tangents drawn parallel to each other. So xy and x dash y dash are the two tangents, and PQ passing through O is the diameter. And there is another tangent drawn from point A to B. It touches the circle at point C. And we need to prove that angle AOB is 90 degree. So whenever you get a question, you just need to think about how to solve and which theorems and properties we will use to solve the question. So you see here that we need to prove here that this angle is 90 degree. This angle is 90 degree. So how can we prove it? Now we know Pythagoras theorem. If we can prove that OA square plus OB square is equal to AB square, then we can say that this angle is 90 degree. Another way is if we can prove that this sum of this angle and this angle is 90 degree, then obviously this angle will be 90 degree. So we are given that these lines are parallel and this is a tangent. So it is easier to prove that the sum of this angle let be 1 and this b angle 2. So 1 plus 2 is 90 degree. It is easy to prove. Why? Because we are given that these two lines are parallel and this is a transversal. So we can use some properties of parallel line. So we'll work on this hypothesis to prove that angle OAB and angle OBC is equal to 90 degree. So once we have formed that mental map that we are going to work on this particular hypothesis or the way to solve the problem. So we go ahead with that. So how to prove that this angle and this angle, sum of these two angles is 90 degree. So what we do this construction. Let us draw a line, sorry, OC. And you see that OC is 90 degree. Angle I means OCA is 90 degree. This angle also 90 degree. Now what do you see? How to prove now? First, let us see these two triangles OQB and OCB. This angle is 90 degree, this angle is 90 degree. This side is common. These two sides are equal. Why equal? Because both are the radius. So what will happen? Triangle OQB is congruent to triangle OCB. So if they are congruent, then what we get? This angle is equal to this angle. Okay. Now we come to this part. You see triangle OCA and triangle OPA. So OPA is 90 degree. This side is common and this side are equal because both are the radius. OC is equal to OP. So triangle OPA is congruent to OCA. So if they are congruent, then this angle is equal to this angle, because in a corresponding triangle, in a congruent triangle, corresponding angles are equal. So what will we get from this? What more property can we use? See, you are given one more thing, that xy and x dash y dash are parallel. If they are parallel, then we know the properties of a parallel line. If you remember, there is something which relates to sum of angles. So the property is sum of interior opposite angle is 180 degree. So what we get? One, what are the opposite interior angle? Angle PAC and angle QBC. So if I give the number 1, 2, and this is 3, and this angle is 4. So what I get? 1 plus 2 plus 3 plus 4. I mean all these are angles is equal to 180 degree. But we have already proved angle 1 is equal to angle 2. Angle 3 is equal to angle 4. So we can write 2 times angle 2 plus 2 times angle 4 is equal to 180 degree. How we get 2 times? Angle 1 is equal to angle 2. So angle 2 plus 2 is 2 times angle 2. Angle 3 is equal to angle 4. So it is angle 4 plus 4, that is 2 times angle 4. And this we can write angle 2. We divide both sides of the equation by 2. So we get angle 2 plus 4 is equal to 90 degree. So this is what we wanted to prove, that angle 2 plus angle 4 is 90 degrees. So angle AOB, angle AOB in triangle is equal to 90 degree. Why? We use the sum of the properties of a triangle. So in the triangle AOB, this angle plus this angle, angle 2 plus 4 plus AOB is equal to 180 degree. 2 plus 4 we have already proved is 90 degree. So angle AOB is 90 degree. So this is how we proved it. So now what I have discussed, I will write it systematically, okay, for the purpose of exam. So I am writing the steps that we have discussed. So in triangle OQB and OCB, these are congruent by RHS. Hence angle OBQ is equal to angle OBC. Similarly, we will prove for these two triangles OPY and OCA. So these two triangles OPY and OCY are congruent by right hypotenuse and side. So angle PYO is equal to angle CAO. So what we get, QBC plus PAC is equal to 180 degree, because QAC and PAC, QBC and PAC, QBC and PAC, these are Sorry, I mean QBC and PAC, the sum of the angle is equal to 180 degree. But QBC is equal to QBO plus OBC. Similarly, PAC is equal to PAO plus angle OAC. So this is what I have written here. So from this equation, what we get? So we get 2 times OBC plus 2 times OAC is equal to 180 degree. Why? Because OBC is equal to QBO, PAO is equal to OAC. So from this we get angle OBC plus OAC is equal to 90 degree. So we go to AOB. AOB. We know that this angle plus this angle is equal to 90 degree, and the sum of the three angles of a triangle is 180 degree. So AOB plus OBA plus BSO is equal to 180 degree. But we already know that this plus this, these are the same angles, is 90. So that means angle AOB plus 90 is equal to 180, or so from this we get angle AOB is equal to 90 degree. Sense proved. In question number 10, we need to prove that the angle obtained by tangents at point A, the two tangents are AC and AB, they subtend an angle A outside the circle, and the angle subtended by the line joining the point of contact of the tangent to the center. So here it is COP. So we need to prove here that this angle, which is outside the circle, subtended by the two tangents, and this angle, the sum of these angles is supplementary. That means this angle plus this angle is equal to 180 degrees. A very easy question. You can see that ABOC is a quadrilateral, and this angle and this angle is both are 90 degree. Why? Because this is the angle subtended by, a line drawn from the center of the circle to the tangent is perpendicular. So this angle is 90 degree. Similarly, this is a tangent. This is the line drawn from center to the on the tangent at the point of contact. So this angle is 90 degree. Sum of these two angles is 180 degree. So we are left with these two angles. Sum of the angles of a quadrilateral is 360 degree. Two angles, these two angles, their sum is 180. So hence the sum of angle A and angle COB is 180 degree. So they are supplementary. So this is what we need to prove. So I have written the same what we have discussed, that the angles, some of the angles of a quadrilateral ABOC is equal to 360 degree. ACO and ABO. So there was a typographic mistake, so that I have corrected. So you see that this angle ABO and this angle ACO both are 90 degree. So we will replace the value of these two angles by 90 degree. So ABO is 90 and ACO is 90. So from this what we get? CAB plus BOC is equal to 180. So we get CAB plus BOC, CAB plus BOC, CAB plus BOC is equal to 180 degree. That means these two angles are supplementary. Hence, proved. So because the sum of angles is 180 degree, that means these two angles are supplementary angles. So in the question, we are given that there is a parallelogram and it is circumscribe a circle. So if it circumscribes a circle, then it is a rhombus. So that means that these sides touches the circle. So while solving these questions, what should come to our mind? First is the property. Property of what is the property of parallelogram and what is the property of rhombus? Parallelogram, opposite sides are equal, opposite sides are parallel. And what about rhombus? All sides are equal. Diagonals intersect at 90 degree. So we need to use either any of these properties. So what is easy to prove that the angles subtended by the tangents also sorry by the diagonals is 90 degree. That is difficult to prove. But we can easily prove that the sides are equal. AB is equal to DC, this is given. We only need to prove that AB is equal to AD. So what we will do? So in the I have drawn the figure as per the question that this is a parallelogram ABCD and this is a circle and this parallelogram subscribes to the circle. So ABCD is a parallelogram and EFGH, these are the point of contact of the sides with the circle. So what do you see? AE and AH, what are these? These are tangents. DH and DG, CG and CF, BF and V, all these are tangents. So we already know that the tangents drawn from a point outside the circle are equal. So this is equal to this and this equal to this. We are already given that AB is equal to DC. So we need to prove that AB is equal to AD. So if we prove that AB is equal to AD, then we have proved that all the four sides are equal. So hence the ABCD will become a rhombus. So we see that AH is equal to AE and DH is equal to DG. I have written this equality in such a way that if we add AH and DH, we get AD. And so if I add these two equations, what I get? AH plus DH is equal to AE plus DG. If I write AE is equal to AH, then the summation will not lead to what we want to prove. Okay, so we need to write the equation in the correct way. So what AH plus DH? AH plus DH is equal to AD. So we get AD is equal to AE plus DG. What about AE and DG? You think that DG is equal to AE is equal to AB? DC is equal to AB because opposite sides of a parallelogram are equal. And DG is equal to half of DC. So we'll prove this that DG is half of DC. So I'll draw this, redraw this figure. So I redrawn the figure. So you see triangle OGD and OGC. So in these two triangles, this angle is 90 degree. This side is common. So in this question, we are asked to prove that if a parallelogram subscribes a circle, then it is a rhombus. That means we need to prove that the four sides of this parallelogram are all equal. The rhombus has all four sides equal. So we draw this parallelogram and parallelogram ABCD and have given E, F, G, H as the name of the points at which the circle touches the sides of a parallelogram. So if you see from A is equal to BH because these are the two tangents drawn from the same point. Similarly, DH is equal to DG and BF is equal to BE and CF is equal to CG. Now we add this. After adding this, we get AB plus BC is equal to AD plus DC. But since it is a parallelogram, so opposite sides are equal. So AD is equal to BC. So we write BC plus BC is equal to, and AB is equal to AB is equal to DC. So we write AB plus AB. Hence, that means what? That AB is equal to hence this proof that BC is equal to AB. BC is equal to AB. Similarly, we can say that AB is equal to AD. Hence, we already know that BC is equal to AB and BC is equal to AD. So AD is equal to AB. AB is equal to DC. So all four sides are equal. So in the question number 12, unlike other questions where we were given more than one information, this in this question we are given the only information that the circle that the triangle circumscribe a circle, and we are given one side of the triangle. So from this one side we can only find the half no, I don't say half, a part of the other side. Like this is 6, so this will be 6 centimeter, and if this is 8, so this will also be 8 centimeter. So only this much information is provided to us. So we'll not be able to solve the way we have been solving the other questions by doing some construction or by looking at the properties of a triangle or the by drawing the perpendiculars. So we'll need to solve this question from the perspective that we are given a only one side, a measure of one side and a part measure of other sides. But we know that that the tangents drawn from a point outside the circle are equal. So we take this as x. So we know that these two sides are, oh sorry, the part of the other two sides which are not known to us are equal. This much we know now. Here in this question we know the measurement of some of the sides of the triangle. We know BC, we know part of AC and AB. So we'll use Heron's formula and also the area of a triangle formula, that is half base into altitude. So we'll do these constructions. So now we get three triangles, COA, AOB and COB, and sum of these areas of this triangle will be equal to the area of ABC. I mean area of ACO, this, area of AOB, this one, and area of BOC, this one. These three will add and make up the area of triangle ABC. So let us find the area of the triangle by the formula. That area of a triangle is equal to half base into altitude. So area of these triangles will be equal to half base into altitude. So this is equal to half a base into altitude. Altitude we know in the all cases altitude is the radius, because this is perpendicular. This is perpendicular to this side. This is perpendicular to this side. So this comes out to be. So similarly we calculate area of the triangle by Heron's formula. So S is the semi-perimeter, AB plus BC plus AC divided by 2. So area is S into S minus A, S minus B to S minus C, the square root of it. So we find S. S is sum of the three sides divided by 2. This side is AB is x plus 6. This one AC, oh sorry, AC is x plus 6, AB is x plus 8 and BC 14. So this side plus this side plus this side divided by 2 is our S. So this comes out to be. So by comparing these two areas, we get this equation, that x plus 14 into 48x is equal to 4x plus 56 square. So this is a 4x plus 56 means 4 into x plus 14. So that means 4 square into x plus 14 square. X plus 14 get cancelled. So we get 48x is equal to 16 into x plus 14. Or from this 16 say, so further from 16 we divide. 16 in the 16, 16 4 ja 48. So by 16 we can divide it. 16 1 ja 16, 16 3 ja 48. So 3x is equal to x plus 14, or x is equal to x will take to left hand side, it will become 3x minus x. So that is 2x is equal to 14, that means x is equal to 7. So from this we get the two sides of these measures. So in the question number 13, we have to prove that a quadrilateral which is circumscribe a circle and the opposite sides, if joined by the joined from the vertices joined by from the point of the center of the circle, the angles made by the opposite sides are supplementary. So this is a quadrilateral, this is a circle, and the side makes an angle of AOB at the center, and CD side makes an angle of COD at the center. So the question says that sum of these angles subtended by the opposite sides at the center of the circle is supplementary. So AOB plus COD is 180 degree. Similarly, for sides BC and AD, BOC and AOD, if the sum of the angles should be 180 degree. We only know this much that the since the quadrilateral is circumscribing this circle, so the tangents drawn from the point A, B, C, D will be equal. So A will be equal to AHD from D point, DH will be equal to DG, and so on. And we know that from the center, if we draw a line by line and which touches the tangent at the point of contact, then the angle will be 90 degrees. So this is the information that we have from the theorems. And we need to prove that angle AOB plus angle COD is 180 degree. So how we go about solving this question? So we take something like we know that the sum of the angles, this is the complete angle from OF starting from here at end and at F. So this angle is 360 degree. Somewhere or how, if we can prove that this angle plus this angle is half of 360, then we'll be able to prove that these two angles are complementary. So let us see triangle AOH and triangle DOH. So you see AO, oh no, sorry, let us see these two triangles OGD and OHD. DH is equal to DG, OG is equal to OH because these are the radius and this side is common. OD is common. So these two triangles are congruent. Why we cannot take these two triangles to prove? Because we don't know how much the relation between OA and OD. That relation we don't know. So we cannot take OAH and ODH. So for the purpose of proving this, the supplementary angles, we need to take the triangle where we have something uh, some knowledge above which coming from the theorems and the properties of the figures. So from the properties of figure we know that OH is equal to OG because both are the radius. We know from theorem that DH is equal to DG. These are the two tangents. So we'll take these triangles. So you'll get, so if we see triangle OHD and OGD, OG equals OH, both are the radius. DG is equal to DH, these are the tangents. OD is common. So these two triangles are congruent. That means that angle HOD, this angle, is equal to angle GOD, this angle. So we'll name these angles as 1 and 2. So these two triangles are congruent. So angle 1, this one, is equal to angle 2. Similarly, we can prove that 3 is equal to 4, 5 is equal to 6, and 7 is equal to 8. So let these be equations 1, 2, 3, 4. So this is 1, this is equation 2, this is equation 3, and this is equation 4. And if we add all these equations, then you will get, so I have rewritten the angles. Instead of 3 equal to 4 and 7 equal to 8, I have written 4 is equal to 3 and 8 equal to 7. Why? Because we want to add these angles 4 and 5 1 and 8, 2 and 3 and 7 and 6. So that's why I have written it like this. And if we add all these equation 1 plus 2 plus 3 plus 4, we get this. But what do you see? Angle 4 plus 5 is angle CO, COB, and angle 1 plus angle 8 is equal to angle AOD. Similarly, 2 plus 3 angle DOC and 6 plus 7 is angle AOB. So we write the angles in place of the numerals. So we know that the angles, some of these angles is 360 degree because it is a complete angle. So COB plus BOA plus AOD plus DOC is equal to 360 degree. But this angle, this COB plus AOD is equal to AOB plus COD. That means each must be 180 degree. So COB is equal to AOD plus AOD is equal to AOB plus COD is equal to 180 degree. Hence we have proved that the angle subtended by the opposite sides at the center is supplementary.